We are live. So welcome back. What a great live demo that was. It was live coding inside a live car, which is kind of awesome. I'd love to mash up Oscar's talk with Roberto's talk and just kind of do some fuzzing on that API. See what will happen to that car. But yeah, what a great demo. So we've got one more talk for the day, and after that, there are these breakout sessions which you can attend. So we've got things about making open source into a real product. Talk there in a breakout session from Kat about putting your community online. You know, lots of us have been doing that. That's kind of what we're doing here as well today. And Ronna and Jessica are also going to talk about how you can support the WWG, the Women Who Go project, which is a great project, and it helps a lot of people. But actually, more importantly, it helps our communities be as diverse as they can, which benefits all of us, frankly. Before we jump into the next talk, though, Roberto, I can see you're waiting patiently. Are you waiting patiently or impatient? I can't tell.
No, I am very patient.
Okay, good. Thank you. So here's the other the other one. See if you can do this one, Roberto. Which name gets used here and why? So you can see I've got this JSON object, and I'm unmarshalling that into a struct here. There's two fields in that JSON object that's name. So which one is going to get used? Which one will print out? Do you have any ideas?
So I would say the uppercase one. Right.
That's right. But let's see why. If we put the struct tag there, it still happens. You still get my name instead of GopherCon EU.
Oh, wow.
And it turns out it's the order that matters. So if we flip the order around here like that, then we get the other one. So JSON is essentially processing each field in order. And since that name matches, it matches and it does it. So that's the final quiz. Right, time for an intro, Roberto. I don't know if you need much of an introduction. You're very well known now, I think. But you are a chocolate factory boffin at Google, is that right?
Right, that's right. I do chocolate and sometimes I also do security. Yeah. So that's my hobby.
Yes, and you're going to talk today about fuzzing, which is a very cool subject, I think. And
I hope so.
One of the questions I had actually for Oscar, and we ran out of time, but I was going to ask him if they've done any fuzzing on their package because it's a kind of low-level binary. It's
right, and if they did, I hope they did it while the car was off, to be honest.
Yeah, although that would just be fun to mash up that with a fuzzing demo and the live car demo as one super demo at the end. I mean, I think that's what we need to get to. Yeah.
What could possibly go wrong?
Well, for anyone that doesn't know about fuzzing, I'm going to get out of the way and leave you in the very capable hands of Roberto. So please welcome him. Clap, do clap. We are checking. Welcome, Roberto Clapis.
So, hello everyone. Matt already introduced me. One thing that he missed out is that I'm a person who likes to sleep at night, like sleep well. And to do that, I usually write unit tests. So today I'm going to show you a simple piece of code with unit tests, and I'm going to show you why I am terrible at writing tests, and also you should not just write unit tests. This is a function that converts a given string to an integer, and if something goes wrong, it just drops anything that was returned and returns a 0. This is an exported function on any library. It's just used to absorb the error. So not hard, it's just 5 lines of code, should be easy. To write unit tests for this thing, you just put some values, and this is something that I expect every one of you to do. If you don't write unit tests, I envy you. I mean, that's some guts you have got there. And if you do, you would probably write something like this. You write passing test, you write some invalid stuff like passing a string, you try with negative numbers, and you also try with a float, because you're parsing integers and you want to be sure that a float does not get approximated a la JavaScript if you try to parse it. Now, at this point, you introduce fuzz testing just because you want to try. The definition of fuzz testing is very long and complicated, and it tells you basically that it's going to try your function with as many inputs as it can in a random way, and it monitors your program. Monitors for assertions to fail and monitors for crashes and panics. The short description is that fuzzing makes sure that some invariants for your code are held true. One example of invariant for my code could be, for example, that if I parse a number and it gets 0, I don't care. It could either be a 0 or be an error. It's not important for my code. But if I get something that is not a 0, I want to make sure that when I serialize it back into a string, it's the same value. This is one simple example, could be many other things that we can evaluate. And so I wrote this simple fuzz code, and after 3 seconds of running it, I found 3 crashers. So I found 3 instances that made my code not work as expected. Needless to say, that gopher represents my face when I was staring at the screen. And the crashers were simple. Numbers with zeros in front of them. Should you parse them as octal? Should you parse them as integers? And if you parse them as integers without the 0, when you serialize them back, there is not going to be a 0. And for you, maybe this might not seem to be an issue, but maybe for your user, it was not considered. Maybe they are relying on an invariant that you just assume to be true. One example is, for example, negative numbers that have a 0 after the minus, or numbers that are written with a plus in front. Do you want to keep that plus, or maybe numbers that are too big? If you write a different fuzz target that just checks if the number matches a regular expression for a number, and then you parse it, sometimes you will get a 0 when the number is too big, and your code just doesn't state that in the documentation. So this is a bit of introduction on why you need fuzz testing. Humans, especially me, are terrible at finding complex edge cases. When you write an API, you write documentation with some assumptions in mind. You have something that drives you to write that code. You have a use case in mind. So you write for that. And in your documentation, you just state something that is about that. So fuzzing doesn't know about it. And so it has been proven to be very effective at finding stuff that the programmer didn't think about when writing the code. And there is one more thing why you should fuzz, which is if you don't fuzz your code, your attackers might. Your attackers will find your code if it is open source. And if it's not open source, well, why? But also, if it is open source, they will try to fuzz your code. And they will find problems. And if they're good hackers, they will just report the bugs, which is nice. If they're not good, you might have wanted to fuzz in the first place. To do that, you need to write fuzzable code. Fuzzable code means that it must be code that is easy to unit test. And if you write code that is hard to unit test, you should probably need to rethink your code a bit. I've done that in the past. I'm not shaming anyone here. It's just sometimes you write the code and you realize it's hard to test, so it's probably bad code to use because the tests are the first users of your code. And then there should be an easy way to invoke just your code. If your code depends on many, many things, you might use too much memory to fuzz, or it might take too long to run your code. So try to make it simple and have a small setup cost. If to test your code, I need to bring up an entire server and connect to its socket, that's going to waste a lot of energy and a lot of time. So try to make it as simple as possible. Moreover, it should be stateless. Everything that happens inside your code, inside the function that you call, should only depend by the fuzz input. The fuzz function will pass you a byte slice, and everything that happens after that call should depend on that byte slice. Don't add state, don't add randomness. Try to be as simple as possible and as straightforward as possible because it's also easier to debug. Now, I'll add a little bit of information. Many people think that fuzz is random testing. For example, in the standard library, there's a package called Quick. that allows you to test with random input. It's not just that. Fuzz applies random mutations to the input that it feeds you and tries to understand which new parts of the code discovered. For example, if there is an if in your code that checks if the string is longer than 10, after a while, the fuzzer will realize that there are two branches and one was explored in one case and the other one was explored in another case. So it's going to add these files, these inputs, to a set of files which is called a corpus, and it's going to explore your code in a thorough way. Even more than what you do when you debug. It's going to craft good inputs to match your code. For example, if it finds that there are some strings hard-coded in your code, it's going to try those to pass some checks. Moreover, when it finds many crashes, and it's oftentimes the case when there is one case that there are similar ones that crash in the same way, it will try to suppress them, because if you cover the same branches, it's probably the same crash. That said, one might wonder, okay, I want to try fuzzing. How do I do that? There are very simple ways to do this, and there are ways that can get very complicated. So the general idea is that you get a byte slice, and the first thing you should do is to decide if the byte slice is of the right size. For example, if you get 1 megabyte and your entire function will only operate on the first 10 bytes, you can just return to the fuzzer, hey, this is too much, I don't care, give me something smaller. This makes fuzzing faster. Then you must derive your input from the byte slice. So if your function takes a byte slice, good, you're down. If it takes a string, you need to cast it to a string. If it takes something more complex, you need to create a function, which I suggest to keep separate, to convert that byte slice to a struct. And then pass that struct to your function so that the fuzz target is separate. Then you call your function, you inspect the return value, and I'm going to expand on this later, and then you panic if something unexpected happens. Yes, you're allowed to panic. This is one of the few cases in which you can panic. Do it as much as you want. This is good. Then you have to return 3 values, which depends on if the input is relevant, irrelevant, or, well, nothing specific. So this is an example of a fuzz target. You transform the byte slice into an input, you pass it to your function that you're interested in, the underlying function here. Then if something unexpected happens, you panic. If something relevant about this input was pointed out by your code, then you return 1. If it is useless and you don't want this input anymore, you return -1. Otherwise, you return 0. This is very simple, very easy. It's quite straightforward. Most of the time, it's easier to write a fuzz target than our unit test, and it's much shorter. Then you run it. This is not yet in the Go standard library toolchain. It's very easy to run. These are all the commands that you need to run, even on a fresh install. Problem is, this is being debated, and there is a proposal to add this to the standard toolchain. It's not there yet, but it works very well, and I use it. So I suggest you do it too. Checking for invariants could be something like, if I take something, let's say JSON, I take an object, I serialize it, and I deserialize it back. It must be the same object. It must look the same, must have the same values. Another thing that you could check is that if was returned, the other values are 0 values or nil, or something that would not cause a misuse. Then you can have a reference implementation, for example, a JSON parser from the standard library, and your implementation that is a very optimized version of it, and you want to check that they behave the same. So having a slower reference implementation is very good when you optimize your code, because it's easy to write slow code. It's hard to write fast code. Moreover, you can check if state variables were changed and they were not supposed to, and if cleanups run correctly. So if the state is the same afterwards. When you get a crash from GoFuzz, you get 3 files. One that contains a raw input that was fed to your function. This might be used, for example, if you're fuzzing something like JPEG. Then you get a quoted representation of that so that you can take it as is, paste it in your test cases, in your unit cases, and then the output of the program that crashes, which is useful because you get a panic, so you have all the structure, all the values, and you can inspect what went wrong. That said, this was the easy part. The harder part is monitoring, because if you run your fuzzing and you find too many crashes, you should stop. Like if you find hundreds of crashes in the first few seconds, there is either a bug in your code or a bug in your fuzz target. You should stop it and go back and restart. Moreover, if you have too much coverage, so you're fuzzing a function that is too big, you should probably try to factor out the stuff that you need to fuzz, and maybe exporting a function just for the fuzz target to have it access just the code that is dangerous, because otherwise the precision of the fuzzer will degrade. And if you start getting out of memory errors, you should probably reduce parallelism or find a way to reduce the input size, as I was describing before. That said, I want to state again one bit. Add your crashes to your unit tests. If you yourself that wrote a code did not think that some input might make your code crash, the person refactoring it, which might be you in the future, which has no memory of the code, as we all do, or someone else, will think about it. So try to help your future self and your coworkers to put the crashes that fuzz found in the unit tests. Now you might be wondering, okay, if I want to fuzz, where do I start? What are the things that I should fuzz? And those are, well, potentially everything, but fuzzing is expensive and it takes time to write the fuzz targets. So everything that is very complex, either in the input it accepts or the range of states it can assume. For example, if you have a complex state machine, it might be the case to fuzz it. Highly optimized code, as I was saying, if you have something that goes fast, it's probably hard to read, like quite hard to read. It's going to have custom allocation, memory management, garbage collector, peaks. And so try to fuzz your highly optimized code. Also, it's going to be fast code, so the fuzzing is going to be effective. And then everything that accepts untrusted inputs and third-party code. For two reasons. It might have bugs, and third-party code is a potential issue in your code base that you don't want to be responsible for. And the second reason is that it might be running under different assumptions. You might assume that your code relies on a library that does one thing, but the library was written for a different reason. And this might hit you quite hard later on. So, the corpus. Don't overdo it. This is my biggest suggestion. I put this slide in so that if you want to read more stuff, there are also notes in the slides that help you how to do it, but don't overdo it. Fuzzing is coverage driven. Few files might be needed for very complicated file formats, but it's going to find out how to feed input to your functions. For example, for me, once I ran it against an HTTP parsing library, it found a correct HTTP2 request in few minutes, which is a complicated thing to do. And now let's get to real bugs. This code is a little bit compact because I needed to fit it into a slide. It's not that complicated. Basically what it does is it takes the data input, the byte slice, it marshals it into a map, and then it marshals it again and unmarshals it again, and then compares the two values. So the idea is, as I was saying earlier, you take an object, you take a string, you deserialize an object, you serialize it again, and you deserialize it again. It should be the same object. It should not yield different results. Well, I ran it on a pretty big and widely used open source library, and in 20 seconds, I found 2 bugs. They were both fixed, but if you look at the last string on the slide, which is 0, colon, a bunch of zeros and a slash, this is not something you would put in your unit test, and this caused a panic. So it's very useful. So useful that when Go 1.13 released a new version, there was an optimization in the JSON package, which caused a panic in a nice in a nice way. I say nice because it was almost impossible to find otherwise. And it was found before Go 113 was widely adopted. So this spared a lot of pain in the community because just continuous fuzzing found the issue. So even the Go standard library is using fuzzing. If you want examples on how to fuzz stuff, you should take a look at this repository, Go Fuzz Corpus by Dmitry Vyukov. And there is examples for every format. There are auto fuzzers for the standard library. The JSON example that I showed was taken from the JSON package in this repo. And if you look at on the right, there is a small column that is a screenshot of that repository. There is a lot of examples. So just take a look. Probably your format is similar to something that already exists. So this might help you get started with a fuzz target. That said, fuzzing is not very user-friendly at the moment. I have to be honest. There have been some problems with modules. It's hard to convert a byte slice to an object, and also it's not integrated with standard toolchain. So there are some proposals and some experiments. I suggest, if you're interested in fuzzing, I suggest you follow the link on the proposal, because if you upvote or comment on it, you can showcase that there is a reason to add this to the standard library and there is need for it. So maybe you can get it as instead of go test stuff, you can go test -fuzz. Maybe in the future, this would be an option. I'm just going to show you now some good results that fuzzing might have had. If you contribute to Chrome, for example, to the grammar or add an HTML element, you should also change the fuzz targets. Chrome doesn't just use unit tests, but it also has continuous fuzzing. And when the portal element was added, people forgot to add the portal tag to the grammar that we used to generate fuzzers. And this caused 2 memory corruptions being completely overlooked. So this was then found by a white hat hacker, and it was rewarded with $8,000 because it was 2 pretty bad bugs. And the only way to find them was to just, well, the easiest way to find them was to just add a couple of words to the fuzz targets in Chrome. So as you update your tests, you should probably update your fuzz targets. How long should you fuzz? I think that this tweet pictures it perfectly. Forever. That's the short answer, because, for example, in OpenSSL, a bug was found after 1.5 years of continuous fuzzing. You're never done fuzzing. But practically, if you ask me how much should you fuzz, I would say as much as you want. As my grandma always says, più tost che niente la mia più tost, which in my dialect means a bit of fuzzing is better than no fuzzing, or something like that. So even if you run a fuzzer for 10 seconds, 20 seconds, that is already going to find a lot of edge cases. Believe me, most of the stuff that I found with fuzzing was found in the first hour. So if you're in doubt on how much to fuzz a bit. Even writing the fuzz targets sometimes make you reason, hey, is this invariant true? Do I want to hold to this invariant or not? That said, if you don't want to use your hardware to fuzz stuff, you can use Google hardware. Google offers this OSS fuzz program, and if you have open source projects, you can just sign up, and Google will offer CPUs to fuzz your library for you. The documentation is very nice, is very straightforward, is easy to set up a project to use OSS fuzz, and you get emails telling you, hey, we found this issue in your code, you might want to take a look. That said, I'm open to questions. If we don't have questions, I can go in depth on one fuzzer that I wrote for something that was not a parser, but I'm open to questions now. Ooh.
We do have some questions, actually, Roberto. First of all, let me clap that. Excellent job. Thank you so much.
Thank you.
One of the questions was, is fuzzing a dev time exercise? You mentioned Chrome does it continuously. Do you see fuzzing has a place in continuous integration and part of the sort of dev toolchain in that way, or is it something you have to sort of dedicate dev time to?
So there are 2 ways you can run fuzzing. First one is to discover new issues, And the second one is to check that the older ones are still fixed. So the easiest way to integrate fuzzing in your toolchain is that when you just run unit tests, you refeed the corpus and just the corpus to your fuzz target, which is going to be 1,000 files. It's going to be quick. And in your cloud or in Google Cloud or in whatever, you have a fuzzer that continuously picks up your code and tries to find new bugs. This is the best way. And it's actually very quick to work in this flow. This is what I do at work.
And does the fuzzing tools, do the tools remember the mistakes before so that they, because it's basically somewhat random, isn't it? Does it remember, have memory of things that failed?
Yes. Yes. One nice thing is that when you run fuzz, it runs continuously, but then you can just Control C, and if you restart it, it restarts from where it was. It picks up where it left off. Right. So yes, it remembers everything.
Very, very cool. If people wanted to follow you and chat to you on Twitter, there's your Twitter name, right?
Yeah, that's me. Also, I see one question which was, what is the 5,000 of coverage mean? Yeah, I mentioned that if you cover too much, fuzz is going to lose accuracy. In order to be accurate and quick, it uses a hash table. And after you have more than 5,000 branches in your code, so an if or else, it starts colliding. So if you go beyond that, you might lose coverage. So your fuzzer thinks it has covered a lot, instead it covered too little.
So what's the unit then that the 5,000 refers to?
Numbers of branches.
Okay.
The amount of branches.
Right. Conditionals and.
Right.
Okay.
Loops.
Yeah, loops. Yeah. Well, we're getting lots of claps. And now we're moving on to our breakout sessions. It's time. So Roberto, again, thank you so much.
Thank you for hosting me.
Yeah, of course, anytime. Okay, if you could stop sharing your screen, that's brilliant. Oh, look at that, so professional, mate. So there's a breakout sessions happening now. Head over to the sessions tab, and then we'll be back at 10 to, so at 50 minutes past this current hour, which is the new way of telling the time. Then we'll see you for some closing remarks, but enjoy the sessions until then. And Roberto, thanks again.
Thank you.